Hey guys, welcome back. So today in this video we are going to solve this particular problem in physics involving pulleys. So here we are. We have two blocks. So block A and block B are attached in both end sides of a rope. And we're asked, what is the acceleration of this particular problem? In this case, we are going to use Newton's second law. Newton's second law. And it states that force, or the entire force, is equal to mass times acceleration. And in this case here, since we have two objects, we have a block A and block B, we are going to write two separate equations from these two particular conditions here. So we're going to write equation number 1 from A and 2 for B. So let's get started. So in this case here, give me a second. So what we have here is that we have to draw a free body diagram for both of these particular object here. So in this case, we're going to start with block A. And in block A, we have our entire force, which is equal to mass times acceleration, and our block A object, which is undergoing, or there's two forces that are within block A, and one of them is a force of tension, and the other one is called the weight, or the force of gravity. So because block B is heavier than block B, because the mass of B is heavier or is greater than the mass of A, I'm going to be assuming that the direction of the motion in the acceleration is going to be going this way. So in that case, if that goes that way, then this block A is going upwards and this block B is going downwards. So in this case, block B is pushing block A towards him or towards it. And in this case, we have to use a sign of convention, because in all or in most physics problems, the quantities that we are dealing with are vectors, and that includes directions. So in this case, we're gonna treat this positive direction going upwards, because A, remember back here, A is going upwards and B is going downwards. So in this case here, we're gonna put a positive sign on A in the upward direction, and the negative sign will go downwards here. Okay, so again, force is equal to mass times acceleration, and this entire summation of the force of tension and the force of gravity will be equal to this force of net force. Let's write this one down. So mass times acceleration, and by the way, this is block A, so we gotta write our own subscript. Mass of A times A equals to the tension of the rope minus the force of gravity. And remember, force of gravity is equal to the mass of the object and the gravity. And the gravity is 9.81 meters per second squared. In this case, we have force of gravity, which goes in the downward direction. And since force of gravity is equal to mass times gravity, we're going to write it this way. So we have M of the block A and G. Now right here is our first equation. Let's do for the other one. So we have our block B here, and B is going downwards. So in that case, our positive direction is going to go here, and right here is our negative direction. So we only have two forces here that are acting on the block, and that is the force of tension and the force of gravity. So again, by using Newton's second law, we are having F of G minus the tension. And note that earlier that the force of gravity is equal to mass times gravity itself. In this case, we have mg. But note that we have to note which block are we using it, because like we have two different blocks, so we gotta be careful about the subscripts that we are using with it. So the mass of B times acceleration equal to mass of B and the gravity. Now we have two equations. We have one right here. Actually, I'm gonna go zoom this one out for clarity. There you go. So right here we have equation number 1, and this right here is our equation number 2. Now we are going to add these two equations here to get the final solution. And I'm running out of space here, so let's just erase some of these parts here, but that we don't need anymore. We don't need this. We don't need this. You know, I'm gonna go write it over here so that we're gonna have more space. So we're gonna add this with this equation here. So mb a equals to mbg minus d. And I apologize about my drawing because I'm not really that good of an artist yet. I'm still practicing, so I still need those 10,000 hours of practicing, right? You know, by Malcolm Gladwell. If you read the book Outliers, it's an amazing book, by the way. So we are going to add this to equation here, and we're gonna have by the way, this force of tension are cancelled out. So I'm gonna go zoom this one in so that I can have better clear way to write this one out, because it's gonna make me more organized in writing it clearly. So ma times a plus mb times a equals to, so right here what I did is I just add this overall left side over here, which goes over here. So this is our left side, and in the right side we have mb times the gravity minus ma and the gravity. Note that we can factor out the gravity and the acceleration, and in that way we can also isolate the acceleration from the entire equation. So in this case, with a few of the algebraic manipulation, we are gonna have a times ma plus mb equals to g times mb minus ma. And if we are going to divide this entire thing here down here, we're gonna have a equals to g times mb minus m sub a over m sub a plus m sub b. And right here is our generic equation in figuring out the acceleration of the object. And note that it might be a little bit harder to configure these particular solutions due to the fact that you guys may have to memorize, but you don't really have to memorize this entire process here. I mean, the only thing that you have to know is that by using Newton's second law, and that by knowing how to draw a free body diagram for these two conditions here, and able to kind of integrate the equation that you derive from these two bodies that you've selected from. And after that, you should be able to figure out these overall equations here. So if you're going to attempt, and by the way, don't try to, because it's terrible. If you're going to attempt in memorizing this entire process here, well, that is going to be your nightmare, because as a physics student, memorization is not really needed as long as you know how to process the process of derivation from this basic equation towards its most complex equations. That should be good enough. especially when you're going into higher level of physics in college or university. It's gonna be hard for you guys to configure or derive some of the most complex equations with calculus, because memorizing the process of integration can seem a daunting process. It's very hard. So I highly suggest to not memorize all of the equations, only the basic ones. So for say, if you're studying dynamics and you're just gonna know the basic laws of Newton's, and in energy and momentum, you just have to note that, oh, the energy of the initial objects is equal to the energy of the object after the motion. It's called the law of conservation of energy. So by learning all those basic principles, and with the proper process of algebraic manipulations, you should be able to figure out the right equation for it. Because literally, you can come up to various equations just by deriving from the basic ones. So in this case here, we have the equation for the acceleration, and if we are going to substitute all the constants, and by the way, gravity here is equal to 9.81 meters per second squared. All right, so note that if m is b minus m a, that's gonna give us, so 104 minus 82 kilograms, that's gonna be at 22 kilograms. And if we are going to add, and by the way, this here is 22 kilograms, but if we are going to add those up, what are we gonna get? So 104 plus 82 is gonna give us 186 kilograms. 186 kilograms. So this entire thing here is equal to 186 kilograms. Now, our gravity is 9.81 meters per second squared. So in this case here, we're gonna have 9.81 times this over here, which is 22 kilograms, over 186, and we have 9.81 times 22 over 186, and that answer should be 1.16 meters per second squared. Awesome. Now that's our solution for this problem. And by the way, if you're going to study it further with the application of kinematics, the three-star equations that you're going to be studying from, by figuring out the initial velocity and the distance and the time, all those stuff, you can use this acceleration to kind of figure out the particular kinematics solution.